Tsunami from dinosaur-killing asteroid had mile-high waves and reached halfway across the world. One wave was 2.8 miles high. The dinosaur-killing asteroid that slammed into Earth 66 million years ago also triggered a jumbo-sized tsunami with mile-high waves in the Gulf of Mexico, whose water traveled halfway around the world, a new study finds. Researchers discovered evidence of this monumental tsunami after analyzing cores from more than 100 sites worldwide and creating digital models of the monstrous waves after the asteroid's impact in Mexico's Yucatan Peninsula. This tsunami was strong enough to disturb and erode sediments in ocean basins halfway around the globe. Study of other Molly Ranch, who conducted the modeling study for a master's thesis in Department of Earth and Environmental Sciences at the University of Michigan, said in a statement. The research on the mile-high tsunami, which were previously presented at 2019 American Geophysical Union's annual meeting, was published online Tuesday, October 4th in the journal AGU Advances. Ranch delved into the tsunami journey immediately following the asteroid's collision. Based on earlier findings, her team modeled an asteroid that measured 8.7 miles, 14 kilometers across and was zooming 27,000 miles per hour, 43,500 kilometers per hour, or 35 times the speed of sound when it struck Earth. After the asteroid hit, many life forms died. The Novanian dinosaurs went extinct. Only birds, which are living dinosaurs, survive today, and about 3/4 of all plants and animal species were wiped out. Researchers are aware of many of the asteroid's pernicious effects, such as sparking raging fires that cooked animals alive and pulverizing sulfur-rich rocks that led to lethal acid rain and extended global cooling. To learn more about the resulting tsunami, Ranch and her colleagues analyzed the Earth's geology, successfully analyzing 120 boundary sections or marine sediments laid down just before or after the mass extinction event, which marked the end of the Cretaceous period. These boundary sections matched the predictions of the model of wave height and travel, Ranch said. The initial energy from the impact tsunami was up to 30,000 times larger than the energy released by the December 2004 Indian Ocean earthquake tsunami that killed more than 230,000 people, the researchers found. Once the asteroid struck Earth, it created a 62-mile-wide, 100-kilometers crater and kicked up a dense cloud of dust and soot into the atmosphere. Just 2.5 minutes after the strike, a certain of ejected material pushed a wall of water outward, briefly making a 2.8-mile tall, 4.5 kilometers wave that crashed down as the ejecta plummeted back to Earth, according to the simulation. At the 10-minute mark, a 0.93-mile high, 1.5 kilometers tsunami wave about 137 miles to 120 kilometers away from the impact site swept through the Gulf in all directions. An hour after the impact, the tsunami had left the Gulf of Mexico and rushed into the North Atlantic. 4 hours following the impact, the tsunami passed through the Central American Seaway, a passage that separated North from South America at the time, and into the Pacific. A full day after the asteroid's collision, the wave has traveled through most of the Pacific and the Atlantic, entering the Indian Ocean from both sides and touching most of the globe's coastline 48 hours after the strike. Tsunami's power. After the impact, the tsunami radiated mostly to the east and northeast, gushing into the North Atlantic Ocean, as well as to the southwest via the Central American Seaway flowing into the South Pacific Ocean. Water travels so quickly in these areas that it likely exceed 0.4 miles per hour, 0.6 kilometers per hour, a velocity that can erode the seafloor's fine-grained sediments. other regions largely escaped the tsunami's power, including the South Atlantic, the North Pacific, the Indian Ocean, and what is now the Mediterranean Sea. According to the team's models, these simulations showed that the water speeds in these areas were less than 0.4 mile per hour threshold. The team even found outcrops or exposed rocky deposits from the impact event on eastern New Zealand's North and South Islands, a distance of more than 7,500 miles (12,000 kilometers) from Chicxulub crater in Mexico. Originally, scientists thought that these outcrops were from local tectonic activity, but due to the age and location in the tsunami's modeled route, the study's researchers pinned it to the asteroid massive waves. We feel these deposits are recording the effect of the impact tsunami, and this is perhaps the most telling confirmation of the global significance of this event, Ranch said. While the models didn't assess coastal flooding, they revealed that open ocean waves in the Gulf of Mexico would have exceeded 328 feet, and waves could have reached heights of more than 32.8 feet as the tsunami approached the North Atlantic's coastal regions and parts of the South America's Pacific coast, according to the statement.